Hello students, myself Archana, your botany mentor, and the chapter we are going to deal with today is environmental issue. That is the last chapter of the syllabus. Without delaying, let's start. So the chapter is all about the environmental issues. What are the issues that our environment is facing? And you know, the biggest issue that our environment is facing today is pollution. So what is pollution? Pollution is any undesirable change, any unwanted change in the composition of water, air or soil. That is called as pollution. And the things, the materials which cause pollution, they are called as the pollutants. So according to NCERT, pollution is any undesirable change. It is any undesirable change in the physical, chemical or biological characteristics of air, land, water or soil. When there is change in the physical made up, in the chemical composition and in the biological composition of land, soil, water or air, that is called as pollution. So this is the definition of the pollution according to NCERT. Now, the agents which cause pollution, they are called as the pollutants. Now, the acts are important. There are 3 important acts which are given in NCERT and we'll learn them year by year. So learn them along with me. There are 3 important acts which are given in NCERT and they are, the first one is the Water Prevention and Control of Pollution Act. I have aligned them according to the years. So the first one which came, it came in the year 1974 and the first act was for the control of water pollution. Then the second act, Air Prevention and Control of Pollution, it came into force in 1981. That means this act, which was for the control of air pollution, it came in the year 1981, but it was changed. There was some modification done in this act in the year 1987. And what is that modification? Noise was included as an air pollutant. Before, up till 1981, noise was not considered as air pollutant. But in the year 1987, there was change in this act and noise was added as an air pollutant. Then came the Environment Protection Act in the year 1986. So you have to learn them along with their years. First one is the Water Pollution Act, came in the year 1974. Second is the Air Pollution Act, came in the year 1981, but it was changed, modified, amended in the year 1987 to include noise in it. And then came the Environment Protection Act in the year 1986. So these are 3 important acts and you have to learn them along with their years. Now let's move on further, that what are the harmful effects of air pollutants? What air pollutants does to air? First of all, air pollutants can cause injury to living organisms, right? They can cause injury to our internal organs, they can cause asthma, they can cause damage to our lungs. Then what they can do? They reduce growth and yield of crops and cause premature death of plant. They can decrease the productivity of plants and can cause premature death of plants. And air pollutant can affect the respiratory system of humans and animals. So these are the harmful effects of air pollutants on plants and on animals. Now let's discuss that what are the ways to remove the air pollutants. How can we remove air pollutants? So to remove air pollutants, first of all, let's understand what are the major air pollutants. The major air pollutants are sulfur dioxide, particulate matters and the unburnt hydrocarbons, the hydrocarbons which are not burnt properly, right? So what are the major air pollutants? Sulfur dioxide, then the unburnt hydrocarbons and the particulate matters. They form the major categories of air pollutants. Now there are 2 major ways with the help of which we can remove the air pollutants from the air. The first one is the electrostatic precipitator. It's a device which is used to remove over 99% of particulate matter present in the exhaust coming out of the thermal power plants. The exhaust which come out of the thermal power plant, it contains particulate matter, and if you want to remove the particulate matter from the air, then we can use electrostatic precipitators, and they guarantee that they can remove 99% of particulate matter from the exhaust. The second method is a scrubber. Scrubber is a device which is used to remove sulfur dioxide from the air. So you have to remember, electrostatic precipitator is used to remove particulate matter and scrubber is used to remove sulfur dioxide from the air. Now let's understand their working. Let's first of all, this is electrostatic precipitator which removes the particulate matter. So from this direction, dirty air goes into the device. So this is the dirty air which has the particulate matter, and it is it is going through the electrostatic precipitator. So how does electrostatic precipitator works? An electrostatic precipitator has electrodes, right? You can see electrodes here. So within the device of electrostatic precipitator, we have electrodes, and these electrodes are maintained at several thousand volts. These electrodes are put on several thousand volts, and because of that, they produce corona that releases electrons. When these electrodes are put on several thousand volts, they release electrons. That means they develop a negative charge around them. That is called as corona. So these electrons attach to the dust particles, giving them a net negative charge. When this dirty air is passed through this electrostatic precipitator, the electrons which are emitted from the electrodes, they combine with the dust particles, and the dust particles also get negatively charged. Then what happens next? The collecting plates are grounded and attract the charged dust particles. This is the collecting plate, right? You can see in the diagram, this is the collecting plate, right? So this collecting plate is grounded and it attracts all the negatively charged particles, and the velocity of this dirty air, the velocity with which we pass this dirty air through the electrostatic precipitator is kept low, so that the dust particles can easily become negatively charged, and this collecting plate, which is grounded, which maintains the positive charge, attracts these negatively charged particles, and these negatively charged dust particles, which are called as the particulate matter, they gets collected on the collection plate, and this is how the particulate matter is removed from the air. That means the air which will come out of the electrostatic precipitator, it will be a clean air. So what is the funda behind electrostatic precipitator? That dirty air is passed through the electrostatic precipitator. The electrodes present in the electrostatic precipitator, they are maintained at high voltage, due to which they emit electrons, and these electrons combined with the dust particles, that means the particulate matter, and the particulate matter in the dirty air becomes negatively charged, and it is get attracted to the collecting plate. Right? That means all the particulate matter, the dust particles, they collected at the collection plate, and the air coming out of the electrostatic precipitator it does not have particulate matter now, right? So this is how electrostatic precipitator works. Now let's understand what is called as a particulate matter. That is important. According to Central Pollution Control Board, CPCB, the definition, the full form can come in the exam. According to CPCB, the size of the particulate matter is 2.5 micrometers or less than 2.5 micrometers. So any dust particle present in the air which have the diameter equal to 2.5 micrometer or less than 2.5 micrometer is considered as the particulate matter. So this is important, and this cause the greatest harm. These are the particles, particulate matter cause greatest harm to the human health, as it can cause breathing problems, irritation, inflammations, and damage to the lungs, and in severe cases can also cause death. Now let's understand the working of a scrubber. So in a scrubber, this is the scrubber. So this is a dirty air, right? From here, the dirty air goes in, and the dirty air has sulfur dioxide in it. It contains SO2. So what is the working of scrubber? In a scrubber, the exhaust is passed through a spray of water or lime. So here, when this dirty air is passed through, this dirty air is passed through a spray of water or lime. This is a spray of water or lime. So what happens that the calcium present in lime, combines with sulfur, combines with SO2 to form calcium sulfate, and thus sulfur SO2 is removed from the air. Right? So from this point, the dirty air is going inside the scrubber, and here there's a spray of lime, and the calcium present in the lime, it combines with SO2 to form calcium sulfate, and thus SO2 is removed from the air. When the air will come out of the device, the air will be clean without any SO2. So this is how scrubber works. Now, let's go to another major problem that causes air pollution, and that is automobiles, the vehicles. So automobiles, they are a major problem for atmospheric pollution. So what are the methods by which we can control the air pollution caused by the automobiles? The first method is use of lead-free petrol and diesel. Lead-free, because lead causes pollution in the air. So one should use lead-free petrol and diesel. The second important thing is use of catalytic converter in the automobiles. Catalytic converters are fitted into the automobiles, and they have expensive metals like platinum, palladium, and rhodium. So catalytic converters are formed of expensive metals such as platinum, palladium, and rhodium. Now, what is the function of catalytic converters in the automobiles? They convert unburnt hydrocarbons. Unburnt hydrocarbons are a very major air pollutants. So catalytic converters convert unburnt hydrocarbons into carbon dioxide and water and carbon monoxide. These are not as harmful to the air as unburnt hydrocarbons are. So the function of catalytic converter is to convert unburnt hydrocarbons into carbon monoxide, carbon dioxide, and water, which are less harmful as compared to unburnt hydrocarbons. Second function of catalytic converter is to convert nitric oxide. Nitric oxides are very harmful for air. So catalytic converter convert nitric oxide into carbon dioxide and nitrogen gas. So this question can directly come in the paper, that what is the function of catalytic converter. So you must remember to convert unburnt hydrocarbons into CO2, carbon monoxide, and water, and to convert nitric oxide into CO2 and nitrogen gas. Now, yes, air pollution and its prevention. How we can control the air pollution. Let's understand it now. So I have just told you that the Air Prevention Control Act, it came in 1981, but it was changed and modified in the year 1987. So let's discuss something about noise now. So if I tell you something about noise, so in general conversation, when we talk to each other, so during conversation, we use 30 to 60 decibel of, the pitch is around 30. So noise can be calculated by sound meter. Noise can be calculated by sound meter, and the unit for this calculation, the unit in units, the units is called as a decibel. Decibel, that is abbreviated as dB, right? So a sound meter calculates the level of noise in the units of decibel, that is dB. So in a normal conversation, the level is 30 to 60 dB, right? But when above 80 decibel, above 80 decibel, the noise is considered as an pollutant, So if any noise has the unit, has the intensity greater than 80 decibel, then it is considered as a agent of noise pollution. And above 140 dB, above 140 dB, it becomes unbearable for our ears to bear the noise, right? Like the noise of jets, the noise of rockets. Okay, so in a normal conversation, the range is 30 to 60 dB. Above 80 dB, it is considered as a noise pollutant, and above 140 dB, it becomes unbearable to our ears and can cause damage to our ears. So, noise is an undesirable high level of sound, which is not very desirable to our ears. That is called as a noise. Now, the NCERT is saying, which is important, a brief exposure to extremely high sound level. If extremely high sound level having the 150 decibel intensity, even smallest exposure to this noise can cause damage to our ears, right? But even the chronic exposure, chronic means continuous exposure, exposure for the longer period of time to a relatively lower noise level, 150 dB brief exposure, damage to air. But below 150 dB, suppose per se 80 dB or 90 dB, this is the lesser noise level. But for a longer period of time, if our ears are exposed to 80 or 90 decibel of air, that can also cause harm to our ears. Okay, permanent damage to our ears. And noise can cause, in the humans, what noise can cause? It can cause sleeplessness, increased heart rate, altered breathing pattern, and it is thus considered stressing for humans. Now, how can we control noise pollution? Obviously, by reducing these, by achieving the means by not honking the horns, by controlling the volume of our DJs and all. But there is a very important thing which needs to be discussed here, and that is called as the green muffler scheme. So what is this green muffler scheme? Wherever there are industries where there is high level of noise, so what is done over there? There are certain plants like the neem plant and the ashoka plant. They have this capacity that they can absorb the sound waves. So wherever there is a production of noise, so around those areas, these kind of plants are planted so that they can absorb the noise and control the noise pollution. This is called as green muffler scheme. So around high noise polluted areas, some plants like neem and ashoka are planted, which can absorb the high sound waves. Which can absorb the high sound waves and can reduce the pollution. This is the green muffler scheme. Now, yes, another method to control air pollution is the use of CNG, that is compressed natural gas. So, in Delhi, we know that Delhi is high polluted area. So, in the year, by the end of 2002, all the government buses running in Delhi were converted on CNG. Now the question comes, why CNG is better than petrol or diesel? So there are three reasons of why CNG is better. First reason is CNG burns most efficiently As compared to petrol or diesel, the burning efficiency of CNG is better. It burns more effectively, right? And very little of this is left unburnt. When CNG is used as a fuel, the production of unburnt hydrocarbons is very less as compared to diesel and petrol. Second reason is CNG is cheaper than petrol or diesel. Third reason is we can cause adulterations. We can adulterate petrol or diesel easily, but we cannot adulterate CNG very easily. So these are the three important reasons why CNG is a better fuel than diesel and petrol. But what is the main problem that CNG is not still widely used in automobiles? Because the main problem is the difficulty of laying down the pipelines to deliver CNG. It is very difficult to plant all the pipelines all over the India so that the supply of CNG can be there. So it is very difficult. So that is why it is difficult for all the people to convert on CNG. Now, the government of India has a auto fuel policy which has stringent rules. There are several norms on which there are several norms which are passed by the Indian government which keep a check on the vehicles, right? And these norms were Euro norms, Bharat stages, Bharat stage 1, 2, 3, 4, 5. These are all the norms according to which the vehicle is passed, that okay, this vehicle is producing so much pollution, so we will not pass this vehicle to the public use. So these are certain norms by the Indian government which says that the sulfur should be controlled at 350 ppm. What is 350 ppm? Parts per million. The sulfur should be controlled at 350 ppm in diesel and up to 150 ppm in petrol. That means the concentration of sulfur should not be more than 350 ppm in diesel and 150 ppm in petrol. And the aromatic hydrocarbons have to be only 42% of the concerned fuel, right? So there are certain norms like Bharat stage 2, Euro 2, Euro 3, which works on the emission done by the automobiles. Now, currently we have Bharat stage 4. We have Bharat stage 4, which is applicable to 4-wheelers, 3-wheelers and 2-wheelers, right? So these were applicable to India at the end of year 2017. Okay. So these norms can help us to control the air pollution by the automobiles. Now from air pollution and noise pollution, let's come to the water pollution. Water Pollution Act came in the year 1974. I just told you. Now, when will I say that this water is not fit for human consumption or this is polluted water? When water contains 0.1% impurity. When water just contains 0.1% impurity in it, then it is unfit for human consumption and it is considered as polluted water. Now, what are those 0.1% impurities? The 0.1% impurities I'm talking about, they can be suspended solids like sand, silt and clay. They can be colloidal materials like fecal matter, like bacteria, like paper fibers, and it can be dissolved materials like nitrates, ammonia, phosphate, sodium, calcium. So all these things together forms they pollute the water. Okay. Yes. Now comes how we will check that the water is polluted or not. So I have told you this in Microbes in Human Welfare in detail, that I have told you what is BOD. BOD is called as biochemical oxygen demand. It is called as biochemical oxygen demand. Told you in Microbes in Human Welfare in full detail that if I take 1 liter of water, and there are impurities in this water, then the amount of oxygen amount of oxygen used by aerobic bacteria, amount of oxygen used by aerobic bacteria to remove organic impurities, from 1 liter of water, that is the biochemical oxygen demand. And obviously, the more the amount of impurities present in the water, the more will be the amount of demand of oxygen by the aerobic bacteria to remove those impurities. That means the more the water is impure, the more will be its BOD. So high BOD indicates dirty water, right? And low BOD indicates that the water is clean. So if the value of BOD is high, that means the water is dirty. And if the value of BOD is low, that means the water is clean. That means you can say that BOD is inversely proportional to purity of water. If BOD is high, water is less pure. And if BOD is less, water is more pure. Okay. So this is the diagram of NCERT given over here. Let's understand this, what the diagram is saying. So this water over here is collected from sewage discharge. That means sewage means household impurities. That means the water over here is highly polluted. So the water is flowing in this direction and we are cleaning this we are cleaning this water with the help of sewage treatment plants, as I have told you in the chapter Microbes in Human Welfare. So when we are moving, right, this is impure water here. This is impure water. And you can see here, beta, that this is showing the BOD. So you can see the BOD is so high over here and the dissolved oxygen in the water is less. If the water is impure, then the amount of oxygen present in the water will be very less, because the bacteria present in the impure water will use that dissolved oxygen, right? So in impure water, the BOD will be very high, but the dissolved oxygen will be very less. And as we move to purify the water, right, so BOD will decrease and the dissolved oxygen is increasing, right? So here we are treating the water. So if we are treating the water, so as we treat the water, the BOD of water is getting decreased, but the dissolved oxygen is increased. That means pure water has less BOD, more dissolved oxygen, and impure water has more BOD and less dissolved oxygen. Okay. Now, algal bloom. There is one more thing which pollutes the water, and that is called as the algal bloom. What happens in polluted water bodies which have high amount of pollutants? Those pollutants act as nutrients for several algae, blue-green algae like Oscillatoria and Abina. And in this polluted water, the blue-green algae grows extensively. And it grows so extensively that it covers the whole water body and uses up all the dissolved oxygen. And this is responsible for the death of the other aquatic life like other aquatic plants and fishes. This phenomenon is called as algal bloom. So algal bloom is not good for water. Okay. Then comes water hyacinth. Yes. You must have heard the name of Eichhornia, that is water hyacinth. I have told you this many times. It is an example of alien species. We have discussed it in morphology and we have discussed it in here in organisms and population also. It is a very problematic weed and it is an alien species. We have introduced Eichhornia from other country because it had beautiful flowers, but now it is the most problematic aquatic weed of India, and it is also called as terror of Bengal. And you know that it, I have told you this in morphology, that it grows with the help of offset. Offset is a means of vegetative propagation, Remember, it grows very rapidly in the water body with the help of offset and covers the entire lake, and it is found in stagnant fresh water. I have told you this in the reproduction in organisms, that it is found in stagnant fresh water, right? So this is a very problematic weed. Then comes, yes, now it is saying, yeah, unlike domestic sewage, wastewater from industries, the wastewater which comes out of industries, it contains heavy metals also, and those heavy metals are not good for water. Now, what metals are called as the heavy metals? These heavy metals are the metals whose density is greater than 5 gram per centimeter cube. Remember this. The chemicals, the water, the chemical effluents which are coming out from the industries, they have heavy metals. And what are heavy metals? Whose density is greater than 5 gram per centimeter cube. And the examples of heavy metals are mercury, cadmium, copper, and lead. They are not good for water and they pollute the water. Okay. Now, what is biomagnification? Biomagnification is a process in which compounds like DDT, mercury, and other insecticides and pesticides, they are not consumed inside the body of living organisms, and they are not digested inside the body of living organism. And when the next organism feed on this organism, it gets the level of the of these materials get increased with increased trophic levels. This is called as biomagnification. So, in the aquatic food chain, biomagnification refers to increase in concentration. It refers to increase in concentration of substances like DDT, right? When you move from one trophic level to another, the concentration of that particular substance increases in the food chain because it is not digested inside the organism. This happens because a toxic substance accumulates by an organism. It gets accumulated in the organism and cannot be metabolized, right? So this phenomenon, the biomagnification, can be seen in case of mercury and it can be seen in case of DDT. Both of them are not metabolized inside the organism and their level gets increased with increasing trophic levels. Now this is the chart of biomagnification given in NCERT. Here you can see this is the water, right? Water. Inside the water, the presence of DDT is 0.03 ppb. This is important to remember. In water, the concentration is 0.003 ppb. ppb is parts per billion. ppb is parts per billion. So, the fishes present in the water, they take this water, the zooplanktons are the microscopic animals which are present in the water. So zooplankton, when ingest this water, the concentration of DDT inside the zooplanktons becomes 0.04 ppm. See, this is ppm and this is ppb. In the whole water body, the concentration of DDT is less, that is parts per billion. But when the zooplankton ingests the water, the concentration is ppm, parts per million, 0.04 ppm. When the small fishes eat the zooplanktons, then the concentration becomes equal to 0.2 ppm. Then when the large fishes ingest, the concentration becomes 2 ppm. And when the fish eating birds eat them, then the concentration becomes 25 ppm. So this is biomagnification. You can see over here. Okay, so as you're seeing here that the concentration of DDT is getting increased with increasing trophic levels, this is biomagnification. There is one correction here. This is 0.5. So in water, the concentration was 0.03 ppb, parts per billion. Then 0.04 ppm, zooplanktons, then small fishes 0.5 ppm, then large fishes 2 ppm, and then finally the birds which eat the fishes, it becomes 25 ppm. So this is biomagnification. Now eutrophication. What is called as eutrophication? Eutrophication is called as the aging of lake. Aging of lake is very natural and very normal, and you must have studied this in the chapter ecological succession, right? A water body, inside a water body, when soil erosion happens and the soil from other areas goes and gets deposited, and in a water body, when the organisms die and they get accumulated in the water body, then slowly and gradually the water body becomes forest. This is called as the aging of lake. Ultimately, the water body becomes a forest. This is aging of lake, which happens naturally. And this natural aging of lake, it takes thousands of years. It takes millions of years, right? So the natural aging of lake is done by the nutrient. When the lake is very young, it has just made up, the water in the lake is cold and clear, supporting very little life. But slowly and gradually, when the water from other sources gets added up into the lake, the water becomes warm and it supports life. And when it supports life, it dies and gets accumulated in the bed. So slowly and gradually, the lake becomes the forest. This is natural aging of lake, eutrophication, which is very normal, not problematic. But what is problematic is cultural or accelerated eutrophication. This is aging of lake done not naturally but by man. So this is man-made. This is man-made, or you can also call it as anthropogenic. So when the aging of lake is done due to the man-made reasons, that is called as anthropogenic aging of lake, or cultural aging of lake, or accelerated aging of lake. So during the past century, what we have done, we have added so much of sewage and industrial wastes to the water bodies that now inside the water bodies there is so much of poisonous and toxic substances that leads to the death of several aquatic plants and animals. This is eutrophication done by man. Okay, and what else we are doing to the water bodies? The heated wastewater flowing out of electricity generating units, right? The power plants where we generate electricity, those power plants, they release water at very high temperature into the water bodies, and that high temperature which are released into the water bodies, that is not good, right? That constitutes another important category of pollutants, right? Thermal wastewater eliminates or reduces the number of organisms sensitive to high temperature, right? So this thermal wastewater is maintained at very high temperature, and when this is released into the rivers or lakes, it cause harm to all those organisms which are sensitive to high temperature and leads to their death. But may enhance the growth of plants and fish in extremely cold areas, but only after causing damage to the indigenous flora and fauna. But if I talk about the extremely cold areas where the water is very cold, when this hot water is released into the rivers, then in some cases it may increase the population of fishes because it is getting the water warmed up, but it causes damage also to the water. So the thermal wastewater is not good for the water bodies. Now, a case study of integrated wastewater management. What is integrated wastewater management? It is a method by which the polluted water is treated with the help of both artificial methods and natural methods. That means we are treating the water with the help of both artificial and natural methods. That is called as integrated wastewater management. And a very, very important example of this is the foam, that is Friends of Arcata Marsh. What is that? I'll just tell you. So in the integrated wastewater management, water is treated or cleaned up in two stages. The first stage is the conventional sedimentation, filtering and chlorine treatment. In the first stage, I have just told you in the sewage treatment plant that first we do filtration, sedimentation, then we treat it with chlorine gas. Then after that, the biologists have developed a series of 6 connected marshes over the hectares of marshland. So what is done, that a land of 60 hectares was taken. 60 hectares land was taken, and that was a marshy area, a marshland. And that 60 hectares of land was converted into 6 small marsh areas. Like the 60 hectares of land was converted into small 6 marshlands. And in those 6 marshlands, various organisms were introduced. Like in one marshland, it was algae. In the another marshland, it was fungi. In the another marshland, it was bacteria. So when the water will flow through this 60 hectare of land, some of the impurities will be removed by algae, some of the impurities will be removed by fungi, some of the impurities will be removed by bacteria. So with the help of these natural methods, the water is polluted. And what will happen in turn, that when the water will move, the algae will absorb the materials from the polluted water, but those materials are good for the growth of that algae, so that will grow. This will also help in the biodiversity conservation and species enrichment. So this is how this program was so good. So in these 6 connected marshes, the 6 connected marshes, what we had in these 6 connected marshes, algae, fungi and bacteria, and they neutralize and absorb the harmful pollutants from the water and purify the water naturally. So where this integrated waste water management was done, it was done in Arcata. The area was Arcata, and all those biologists who have done this thing in the area Arcata, they are called as FOAM. They are called as FOAM. The full form can come. What is the full form of FOAM? The full form of FOAM is Friends of the Arcata Marsh. The full form of FOAM is Friends of the Arcata Marsh. That means all the biologists which have done this thing, the wastewater management with the help of natural methods, those all biologists are called as FOAM, Friends of Arcata Marsh. Then another method of treating wastewater is, another method of controlling the wastewater, the water pollution, is eco-sand toilets. The sewage water contains the fecal matter also, right? And it gets disposed of into rivers and lakes. That pollutes the water. So we can use the eco-sand toilets. What is eco-sand toilet? It is a sustainable system of handling the human excreta, right? The human excreta, instead of throwing it into the rivers and lakes, the human fecal matter, the human excreta is collected in the dry form and in the composting toilets. The fecal matter is converted into the dry compost, which can be used as fertilizers in the fields. Okay, so this is very cost effective and can prevent the water pollution. Okay, so the eco-sand toilets are used in many areas of Kerala, and it is also used in Sri Lanka. So in India, the eco-sand toilets are widely used in Kerala. Okay. Now comes the solid wastes. The solid waste which can cause the pollution. The solid waste, according to NCERT, includes paper, food waste, plastics, glass, metals, rubber, leather, textile, etc. These all are considered as the solid waste. Now, what are the methods by which we can dispose of these solid wastes? The first method is sanitary landfills. What we do, that we dig the area, and then we fill that area with the waste material, with all the solid waste. So we fill these solid waste into the depression we create into the soil, right? This is sanitary landfills. Now, all the waste, all the solid waste we generate can be classified into three categories. The first category is the biodegradable waste. That waste which can be easily biodegradable, which can be easily broken down into simpler compounds by bacteria or fungi. That is biodegradable waste, like animal bodies, animal dead bodies, plant parts. These all are biodegradable waste. Then the recyclable waste, the waste which can be recycled, like plastic. Then comes the non-biodegradable waste, which cannot be degraded, cannot be decomposed, right? So there are several methods to control them. Biodegradable waste, we can control, how we can help in controlling biodegradable waste? By separating the biodegradable waste from other waste, and this waste can be dealt by bacteria and fungi. Recyclable waste, we should, the kabadiwalas, they help us to, collect the plastic and the iron metal waste, and then that can be reused again and again. And the non-biodegradable waste, it can be dumped into the sanitary landfills. Now, there are several other wastes which are generated by other sources, like hospitals. Hospitals generate hazardous waste, and the hospital waste contains disinfectants and other harmful chemicals and other pathogenic microorganisms also. So the waste which is generated from hospitals should be carefully treated, and the use of incinerators is used for hospital waste. So this is important, how hospital waste, which controls harmful bacteria and viruses, which contains disinfectants and several other syringes and all. So the hospital waste is disposed of with the help of incinerators. These are devices which are maintained at high temperature, and the hospital waste is dumped into these devices. So remember, hospital waste are degraded with the help of incinerators. Then comes the irreparable computers, the electronic waste. Then comes the e-waste, which we also called as an electronic waste. So e-waste, how do we dispose of e-waste? There are two methods to dispose the electronic waste, like the used mobiles, like the used TVs and the computer laptops. So e-waste, first either burned in landfills. The first method to dispose of e-waste is to bury it in the landfill. Second is the use of incinerator. So two methods, bury in landfill or use incinerator. Then over half of the e-waste, this line is important, over half of the e-waste generated in the developed world are exported to developing countries, mainly to China, India and Pakistan, where metals like copper, iron, silicon, nickel and gold are recovered during recycling process. It says that around half of the e-waste of the world is generated in developed countries like Russia, America, and then the e-waste from these developed countries is exported to the developing countries like India, Pakistan, where from this e-waste we remove all the expensive metals and we use it again and again. Right? Unlike developed countries which have specifically built facilities for recycling of e-waste, in the developing countries there is no such method, right? The developed countries has the highly developed methods for removal of e-waste, but not the developing countries. Okay, now let's move on further. Now a case study for remedy for plastic waste. How can we, counteract the plastic waste problem? So there's a case study, and this problem was tackled by the person Ahmed Khan. So Ahmed Khan, what he did, he used this is important because this question has come in NCERT. What he did, he formed a material called as a polyblend. This is important. He formed polyblend. What is polyblend? A polyblend is a fine powder of recycled modified plastic was developed then by his company. This mixture is mixed with bitumen that is used to lay roads. So what is polyblend? This is important. What is polyblend? A polyblend is a mixture of bitumen. It's a mixture of bitumen plus the plastic waste. So he combined the plastic waste with bitumen and formed a specific thing called as polyblend, and this polyblend was used to make roads. So this is a very efficient method to use the plastic waste, right? So in a collaboration with a college in the Bangalore, Ahmed Khan used polyblend to lay roads, right? And this was, around more than 40 kilometers of roads in Bangalore has already been laid with the help of polyblend. So this is a very good example of using the plastic waste. Now, the case study of organic farming. Now, first of all, let's understand what are agrochemicals. Agrochemicals. Agrochemicals are the pesticides, the insecticides, and the chemical fertilizers. These all are called as the agrochemicals, the chemicals which are used in the field of agriculture. And we know that pesticides, insecticides, and the chemical fertilizers, they have a very harmful effect on our health, on the water bodies, on the aquatic life. So there is a concept of organic farming in which we do not use this agrochemicals. So integrated organic farming is a cyclical zero waste procedure where waste products from one process are cycled. That means it is a method in which there is a zero wastage. The waste material from one process is used in the another process, and here no chemical fertilizers, no chemicals are used. Okay, so this case study was done on Ramesh Chandra Dagar. He was a farmer in Sonipat. Sonipat is in Haryana, right? So what he did, he includes he reared bees, honeybees. Then he reared the cattle and the water harvesting, the composting, agriculture, right? So how he integrated all these things? He reared honeybees, and these honeybees, they helped in the process of pollination. Then he reared cattle, cows and buffaloes. The cow dung from the cows and buffaloes, it was used as a manure for the agriculture field. So this is the integrated organic farming where products from one organism can be used in the field of agriculture. So here there is no need of chemical fertilizers. Okay, natural fertilizers are used. So this is a very important case of organic farming, which increases productivity also, and there is no wastage. Then comes the radioactive wastes. Now this is important. First of all, initially in the previous time, nuclear energy was considered as a non-polluting way for generating electricity. Nuclear power plants, the nuclear power plants were used to generate electricity, and it was not considered as a means of pollution. It was considered that nuclear power plants, oh, they do not cause any pollution. But later on, it was realized that the use of nuclear organism has, nuclear waste is the most problematic and the most problem causing waste. Nuclear waste can cause problems not to one generation but to coming generations. So there were two cases of accidental leakage of the nuclear waste. The first one was the 3 Mile Island in US, in USA, right? And the another example is Chernobyl, that is in Ukraine. It was in Ukraine, USSR. Yeah, right. Right now, the Ukraine is a very hot topic of discussion. So USSR, when the states were united, so the Chernobyl incident was a talk of the town. So these are the two important incidents: the 3 Mile Island in USA and the Chernobyl in Ukraine, USSR. These are the two important cases of accidental leakage of, and you know that in Chernobyl, even today, the genetics of the people over there is affected, right? They are, they still are born deformed. So radiation that is given off by the nuclear waste is extremely damaging, and it can cause mutations, and we know that mutation can be inherited from one generation to the another. Now, what is the method that how can we dispose of this nuclear waste? This was a question asked in NEET. What is the method of dealing with this nuclear waste? How can we deal with the nuclear waste? So nuclear waste can be, they are packed into containers. The nuclear wastes are packed into containers which are shielded very, carefully. And then these containers are buried into 500-meter deep into the rocks. Not in sea, remember, not in sea, into the rocks. So these containers containing the nuclear waste, they are buried into 500-meter depth into the rocks. So this is the way how we dispose of the nuclear waste. Okay, so these containers are buried within the rocks about 500-meter deep. Okay, so this is radioactive waste. Now let's understand greenhouse effect and global warming. What is greenhouse effect and what is global warming? If I try to make you understand what is greenhouse effect, then we can take the example of a car. If you're sitting inside a car in sunlight, then after a point of time, you will feel very hot inside the car, because the sunlight entering into the car, it is getting, arrested into the car, because the glasses, they're not allowing that sunlight to go out, and that is causing the heat inside the car. This is greenhouse effect. Okay, now greenhouse effect is not bad. It's not a bad effect. It's a very, very good effect for Earth. But now the meaning of greenhouse effect has changed, because it has now become a cause of global warming. Now let's understand. The greenhouse effect is a very natural process. The greenhouse effect is a naturally occurring phenomenon that is responsible for heating of Earth's atmosphere. Like, because of this greenhouse effect, life is possible on Earth. On another planets, there is no method of retention of this heat. Because of this heat in Earth, the life is flourishing. So greenhouse effect is very essential for heating up the Earth's surface. Otherwise, the Earth would have been so cold that it would have not been supported the life. So without the greenhouse effect, if greenhouse effect was not there, then the average temperature at the surface of Earth would have been minus 18 degrees centigrades. If the greenhouse effect is because of the atmosphere we have around the Earth, that atmosphere do not allow the sunlight to escape, and because of that, heating effect is generated on the Earth. If greenhouse effect would not have been there, the temperature, the annual average temperature of Earth would have been minus 18 degrees centigrades, in which the flourishment of life would have not been possible. But now the average temperature of Earth is 15 degrees centigrade. Remember this, because of greenhouse effect, the average annual temperature on Earth is 15 degrees centigrade. But if it would have been absent, it would have been minus 18 degree centigrades. Now let's understand the greenhouse effect. So let's to make you this understand. This is Earth, right? This is Earth. This is the surface of Earth. And this is the atmosphere of Earth, which has many gases, right? So around the surface, we have atmosphere. So what happens? Sunlight, the solar radiation, enters into the Earth's atmosphere. Okay, so what happens? Let's read the lines of NCERT which are important. Clouds and gases reflect about 1/4 of the incoming solar radiation. What it is saying that the clouds present in the atmosphere, they reflect about 1/4. So 1/4 of solar radiation is reflected. 1/4 of solar radiation is reflected. This is important. The clouds present in the atmosphere of Earth, they reflect 1/4. They reflect 1/4 of the solar radiation entering into the atmosphere of Earth. Then almost half of incoming solar radiation fall on Earth's surface. Approximately half of the solar radiation falls on Earth's surface. So how much solar radiation falls on Earth's surface? Half of solar radiation falls on Earth's surface. So about 1/4 is reflected by the clouds. About half of the solar radiation falls on the surface of the Earth, right? A small proportion is reflected back. What happens that a small proportion, then what happens when this when this solar radiation hits the surface, then small proportion of it is reflected back by the surface of Earth. About half of the solar radiation which is hitting the Earth's surface, about small proportion of that is reflected back, right? Is reflected back. Earth's surface re-emits heat in the form of infrared radiation, but part of this does not escape into space as atmospheric gases. What happens that when, see, this is the part, about half of the solar radiation is hitting the Earth surface, and in return what happens, some amount of it is instantly reflected back. But when this Earth surface has absorbed the solar radiation, after absorbing the solar radiation, the surface of Earth, the Earth has absorbed the solar radiation. After absorbing it, the Earth emits the infrared radiation. So surface of Earth, after absorbing, it re-emits the infrared radiations, and you know that infrared radiations are the radiations with long wavelength. They are the radiation with longer wavelengths, right? So when the Earth's surface re-emits these infrared radiations into the atmosphere, then they get trapped. They get trapped into the Earth atmosphere. That was good. But in today's scenario, the atmosphere has very high concentration of methane gas, CO2, which do not allow these infrared radiations to escape the atmosphere, right? The infrared radiations emitted by the Earth's surface, some part of these radiation used to be in the Earth atmosphere, which was used to create greenhouse effect, very good, and some part of it used to escape the atmosphere. But now a larger part of these radiations are are retained in the Earth's atmosphere, which is not required, which is more than the requirement, and that is causing the global warming. So this is how this this is global warming. So greenhouse effect is not bad, but the gases which are present in the atmosphere of Earth now, they are retaining the amount of these infrared radiation more than the requirement, and that is causing the global warming. So see, these are the greenhouse gases in the atmosphere which are not allowing the escape of these infrared radiation and causes the global warming. So that means the increase of greenhouse gases in the atmosphere of Earth is causing the global warming. And what are those greenhouse gases? Very important. In the greenhouse gases, 60% is CO2. 60% is CO2, 20% is methane, 14% chlorofluorocarbons, which are generated by refrigerators, and 6% nitric oxides. Very important. 60% carbon dioxide, 20% methane, 14% chlorofluorocarbons, and around 6% nitric oxides. Okay, so during the past century, the temperature of Earth has increased by 0.6 degrees centigrades. Due to global warming, the annual temperature of Earth has been increased by 0.6 degrees centigrades. Scientists believe that this rise in the temperature is causing deleterious effects, which are causing a very harmful effect called as El Nino effect. What is El Nino effect? El Nino effect is an effect in which the warm currents are produced in the oceans. These are the warm currents produced in oceans and sea, and they are causing deleterious and harmful effects in the aquatic life and in the climate change. So India, the climate of India is very much affected by the El Nino effect. You can see that this leading to increased melting of polar ice caps in the Himalayan snow cap. Okay, this is leading to the melting of glaciers, which is not good. Now, how can we control global warming? What are the methods? First of all, include cutting down of use of fossil fuels, because fossil fuels releases CO2 and methane into the air. Improving efficiency of energy usage, reducing deforestation, we should not cut forests, planting trees, slowing down the growth of human population. These all are the methods with which we can control global warming. Now, ozone depletion in the stratosphere. What is ozone first of all? You know, ozone is O3. Ozone gas is O3. You know that molecular oxygen is O2 and atomic oxygen is simple O. So atomic oxygen is O, molecular oxygen is O2, but ozone is O3. Okay, so this ozone is present in our atmosphere. And what is the function of ozone? Let's first of all categorize the ozone. There are two types of ozone: bad ozone, good ozone. Now, what is a bad ozone? A bad ozone is an ozone which is formed in the lower atmosphere. Lower atmosphere means troposphere. So the ozone which is formed in the lower atmosphere is not good, it is harmful, and that is called as the bad ozone. The good ozone is the ozone which is formed in the upper part of the atmosphere, that is stratosphere. The upper part of the atmosphere is stratosphere. And what is the function of this good ozone? It protects us from the ultraviolet radiations that come from the solar radiation. Okay, now how do we measure the thickness of the ozone in the atmosphere. The thickness of the ozone layer is measured in the unit Dobson unit. It is measured as Dobson units, that is DU. Okay. Now you must have heard that there are cases of ozone depletion. That doesn't mean that there is a hole over there. No, that there is a hole in which, no, there is not such a hole over there. That means the layer of the ozone is getting thinned. Okay, this is called as the thinning of the layer. The hole is the thinning of the layer. And the ozone depletion is widely occurring in the stratosphere, and it is marked over the Antarctic region. It is marked over the Antarctic region, and this is called as the ozone hole, right? This is called as the ozone hole. So this ozone hole was first reported over the Antarctic region, and this is seen between late August and early October. So ozone hole, that is thinning of the ozone layer in the stratosphere, is seen over the Antarctic region every year between late August and early October. Okay. Now let's understand the types of UV rays. There are three types of UV rays: UV ray A, UV ray B, UV ray C. The wavelength of UV ray C is the least, and the wavelength of UV ray A is the most, 300 to 400 nanometer. Okay, so UV ray A enters the Earth's atmosphere. The UV ray A enters the Earth atmosphere, and it is not very harmful for us, not very harmful. Okay, about half of UV ray B is absorbed. About half of UV ray B is absorbed by ozone layer, and some of it enters into the Earth's atmosphere. But UV ray C is lethal. Lethal means it can instantly cause death. That is why the ozone layer does not allow the UV ray C to enter into the Earth atmosphere. So UV ray A is not very harmful. It is harmful but not very harmful. So UV ray A enters into the Earth's atmosphere. UV ray B, almost half of it is absorbed by the ozone layer, and some part of it of UV ray B enters into the Earth's atmosphere. But UV ray C, no, it does not enter into the Earth's atmosphere because it is lethal to the organisms. So there is something which is important in NCERT, that UV radiation of wavelength shorter than UV ray B, are almost completely absorbed by Earth's atmosphere. What it is saying, what NCERT is saying, UV radiation of wavelength shorter than UV ray B. So that means it is talking about UV ray C. You have just seen that the wavelength of UV ray C is lesser than the wavelength of UV ray B. That means the UV ray C is completely absorbed by the atmosphere, and UV ray C does not enter the Earth atmosphere. Okay, but UV ray B damages DNA, but some part of, about half of the UV ray B is absorbed by the Earth atmosphere, but some part of it enters into the Earth atmosphere, and it can cause damage in DNA. Remember what? UV ray B damages DNA, can cause mutation, it can cause aging of skin. That is why in the sunscreen we use, we protect our skin from UV ray A and UV ray B, because UV ray C does not enter the Earth's atmosphere. Damage to skin cells, various type of skin cancers. In human eye, cornea absorbs UV ray B radiation, and a high dose of UV ray B can cause inflammation of cornea, called as the snow blindness. So these all are the damaging effects of UV ray B. which can cause skin cancer, which can cause mutations, which can cause damage to DNA, which can cause inflammation in the cornea of eye, that is called as snow blindness, and it can also called as the permanent damage to the eye. Now, recognizing the deleterious effects of ozone depletion, there is a very important thing called as Montreal Protocol. Montreal Protocol was signed in Canada in the year 1987, but it became effective in the year 1989. This is very important. So the question directly comes, what is the purpose of Montreal Protocol? This question has come in NEET. The purpose of Montreal Protocol was to reduce the ozone depleting substances. All those substances which can cause damage to ozone layer, to reduce them was the purpose of Montreal Protocol, and it was signed in Canada in the year 1987, but it became effective in the year 1989. This is important. Okay, and it controls the emission of ozone depleting substances. These are called as ODs. These are called as ODS, ozone depleting substances. Okay, and the major ODS, the major ozone depleting substances are CFCs, that is chlorofluorocarbons, and these chlorofluorocarbons are emitted by the refrigerators. Okay, so this is important. Now, degradation by improper use of improper resource utilization. Okay, so as we know that by the uncontrolled use of soil, now the farmers, they do not keep their land bare for some period of time. They overuse the soil, they exploit the soil. That can cause soil erosion and desertification. So what is soil erosion and desertification? Because of over cultivation, because of unrestricted grazing by animals, deforestation and poor irrigation facilities, the nutrition present in the soil is getting depleted. The water content in the soil is getting depleted, right? Then water logging and soil salinity. What happens that sometimes we waterlog our soil. We provide water which is required, which is not required, right? So water logging is not good for the fields. Providing water which is not required. So water logging is bad for the fields. And the soil, the salt content, the increased salt content in the soil can also reduce the growth of crops. So because of the overuse of the soil, the soil nutrients are getting depleted. Now, what is deforestation? The meaning of deforestation is to cut the forest. When we cut the forest, there are three words: afforestation, deforestation, reforestation. Afforestation means to plant the trees where there were no trees. Reforestation means to plant the trees where the plants have been cut and now we are reforesting them. Deforesting means to cut the forest. Okay, so these lines are important. Almost 40% forests have been lost in the tropics compared to only 1% in the temperate regions. Tropics are the areas near to the equator, temperate which are away from the equator. So what we have lost 1% of the forest cover in the temperate areas, and we have lost over 40% of the forest cover in tropical areas. This is important, remember this. Okay, now let's talk about India. In India, forest covered about 30% of the land of India in 20th century. So in 20th century, about 30% of the land of India was covered with forest. By the end of the 20th century, it shrunk to 21.54%. It reduced to 21.54%. So now there is a policy called as National Forest Policy. This is important. This question can come. National Forest Policy came in the year 1988. What is a National Forest Policy? It says that there should be 33% forest cover for the plains and 67% for the hills. It says that there should be 33% forest area in the plain areas and there should be 67% forest cover in the hills. So remember this, 33% in plains, 67% in hills according to National Forest Policy came in the year 1988. So this data, the data in this paragraph is important. Now, what are the reasons of this lost forest cover? One of the reasons is slash and burn agriculture. What is slash and burn? The farmers, what they used to do, they used to move. This is also called as jhum cultivation. Jhum means to move. They used to cultivate the area. Then what they used to do, they used to burn the leftovers and then move to another areas. So in the previous time, it was a good practice because this area which was previously cultivated and now left for several months, it used to rejuvenate itself. But now these days it has become a malpractice. How? Because this area is not left for several months. Just after just after a month, next crop is sown. So because of this, the nutrition of the soil is getting depleted. So this is one of the major reasons of the lost nutrition of the soil. Okay. Now, one of the major causes deforestation. Now, what are the consequences of deforestation? One of the major effects is the enhanced CO2 in the atmosphere. Because of deforestation, the CO2 concentration will increase in the atmosphere, and deforestation will also cause the loss of biodiversity and habitat destruction. It will disturb the hydrological cycle, it will cause soil erosion, and it will lead to desertification. These all are the consequences of deforestation. Reforestation, we know that if we have deforested the area, then planting the forest again over there, the plants again over there is called as reforestation. Now there are certain cases, there are certain case studies, like in the year 1731, in Jodhpur of Rajasthan, there was a community, very important community called as the Bishnoi community. So there was a very important woman in the Bishnoi community, and that was Amrita Devi. So Amrita Devi, this king, the king of Jodhpur, he went on to cut the whole forest. But Amrita Devi, she gave the members of her community, and she gave the life to protect the trees of Jodhpur. And now in her memory, there is an award called as Amrita Devi Bishnoi Wildlife Protection Act. Right? So this is one of the case studies. So Amrita Devi, member of Bishnoi community, she laid down her life for the protection of forests. And the second movement is the Chipko movement, very important. Chipko movement was in the areas of Garhwal Himalayas, Uttarakhand, right? So in 1974, this movement was initiated by the person Sundar Lal Bahuguna. It was initiated by the person Sundar Lal Bahuguna. Okay, so this movement in 1974, you have to remember the year. This movement in 1974 was responsible for it gained the attention of world because they hugged the trees and laid down their lives. Now, joint forest management, this is important. Joint forest management, it came in 1980s. This is important. Joint forest management came in the year 1980s. This is the strategy of Government of India, that with the help of local people, because the local people has a very good knowledge about the plans in a particular area. So with the help of the local people, we can conserve the forests and the biodiversity. This is joint forest management. And in the return, in the reward, we can provide them with the wood, with the timber, and with the, medicines, gum and rubber. So this was joint forest management. Now let's discuss some of the important questions which had come in the NEET. This is the question of NEET 2021. So you will have an idea that what kind of question comes from this chapter. The question simply asks, Dobson unit are used to measure thickness of, that Dobson unit is used to measure thickness of ozone. Simple question. Then question of NEET 2020. Snow blindness in Antarctic region is due to snow blindness. We know that snow blindness is the inflammation of cornea because of UV ray B. So let's see. Inflammation of cornea due to high doses of UV ray B, high reflection of light, damage to retina, or freezing of fluids. Obviously, inflammation of cornea due to high doses of UV ray B. So you have to read the lines of NCERT line by line, and then your chapter will be prepared. These are the very simple questions direct from NCERTs. Again, this is question of NEET. This is question of NEET 2019. A species that was introduced. No, this is a question of 2020. A species that was introduced for ornamentation but has become a troublesome weed. I have just told you that we have taken a plant for beautiful flowers, but now it has become a problematic weed of India, that is Eichhornia, water hyacinth. So the answer is Eichhornia. Then this is the question of NEET 2019. This is saying, which of these following methods is the most suitable for disposal of nuclear waste? How nuclear waste is disposed? Bury the waste within the rocks, shoot the waste into space, bury the waste in Antarctica, or dump the waste in the deep ocean. We know, bury the waste within rocks deep below the earth surface. So first, direct lines from NCERT. These are direct lines from NCERT. Montreal Protocol, I have just told you, Montreal Protocol is for the control of ozone depleting substances, right? So it is for the control of emission of ozone depleting substances. Which of the following pair of gases is mainly responsible for greenhouse effect? Greenhouse effect, mainly CO2 and methane. So the answer is carbon dioxide and methane. So you can see, very simple and direct question from NCERT. So you have to read your NCERTs line by line, learn all the datas from NCERT. The years are important, the datas are important. Okay, so this is it. So I hope you have understood the chapter well. So now read your NCERTs, learn it by heart, and the chapter will be prepared. Okay, all the best. Bye all.